All right, so at this point, you've gone through your notes, you have them filled in and completed out. The focus here was net force, balanced force, unbalanced force, and acceleration. So a lot of new things. So the summary questions here are practice with those new terms and diagrams. So that's really what we want to break down today. Just a quick recap, net force we'll be calculating for, that's the sum total of all forces acting on an object. So we saw if forces are acting in the same direction, we're going to add them together, just like that horse cart example from the notes. If the forces are in opposite directions, we will subtract them from each other. And when we calculate out net force, we're going to find that there's really two totals that we could get. We could either get a balanced force where everything equals out to 0, or we'll get an unbalanced force where things don't equal to 0. So tug-of-war is a really great example for those. Tug-of-war, for example, if we look at these two arrows, we notice that they're opposite directions. So I know I'm going to be doing some subtraction. And they look the same size, so that means their values are going to be equal. So when I do my calculation of net force, I'm simply going to take 5 minus 5, and that's going to give me a net force of 0. Okay, down here, I notice my arrows are, again, different directions, so I'm going to subtract. And I see that the arrows are different amounts. So I would notice, okay, one is bigger and one is smaller. So when I go to do the subtraction, I'm going to end up with a net force that is not 0, telling me that object has some sort of motion to it in the direction of the bigger force. So because the 10 is the bigger force, the net force here is 8 to the right. Whereas up here, the net force is 0, meaning the object either has no motion whatsoever, so the tug-of-war is at a standstill, or it's moving at a certain direction in a constant rate. It's not accelerating, not speeding up, not slowing down, but staying consistent, so I don't have a change in the net force. So there's a couple practice problems down here. These were all labeled for you on your notes. Just get my labels in. So here we should have recognized that these are opposites, so we're subtracting. We simply take the biggest minus the smallest, and you're going to end up with a net force of 7. And then the direction is also part of it. We know this is moving to the right, again, because that's the bigger arrow and therefore the bigger force. So that one's the winner, if you will, moving that object to the right. Here, again, opposite forces, so I'm going to be subtracting. Net force is going to be 0 or balanced. So I don't have a direction because this object is likely not moving. Again, it could be moving at a constant rate, but I don't have all the details there, so we say either not moving or moving at a constant rate. And then the last one here, a subtraction again, going opposite direction. I'm always going to do big minus small, doesn't matter which one is left or right, giving me a net force of 6. And then looking at my winning force, or the larger of the two, that's this guy, to the left for my net force. Awesome. The last little chunk of notes here was acceleration. So you probably learned something new here. Typically we said acceleration is speeding up, but also we learned it's not just an increase in speed, but also a decrease in speed or a change in direction. So an object can be doing one of those things or all of those things. So when you looked here at the accelerators, you should have noticed that all 3 of these were in fact accelerators. They all fit our definition of acceleration. So right now you're watching the summary review video. So I kind of did a quick overview of the notes. You should be able to fill in these blanks with some of the definitions from the notes both on Monday and today. Okay, here's where it gets a little bit tricky, where we have these free body diagrams that we're looking at. So we want to practice a few of these. So what I'm going to do here is start some of them for you. I'm not going to go all the way through because I want you to be able to try that, but we're going to start some. Okay, so skip around, do what you need assistance with, and as always, reach out. So here, observe the free body diagrams, and under each, circle whether the forces are balanced or not. So determine what the net force is, balanced or not, using the net force, and then direction if it's there. So here I've got two forces, one up. I can see this is tension force, so I know the object is hanging from something. And then here's gravitational force. That's always going to be my downward force because gravity's working on every object. I notice they're going opposite directions, so I'm going to do a subtraction, big minus small. I'm going to calculate that out. That is going to be my net force in newtons down here. And then the direction, I want to look for the largest arrow, right? I want to see, well, which of those two forces is the winning force, essentially, cluing me into the direction that object is going to go. So in this particular problem, I have two choices, either up or down. Okay, so similar problem here. This one, notice you've got four forces to kind of fend with, and you're always going to work the opposites. So I'm going to calculate these two, and I'm going to calculate these two. And you should be able to figure out your net force and the direction from there. Here, name the forces. So just like up here, air resistance, gravity, tension, friction, all those things, you should be able to fill those names in. So for example, this one, gravitational, you should always know that's going to be that downward force. So each one of these is going to get a name from those notes from Monday. So you might need to look back, like we said, to those part 1. And then looking at the diagram, you don't have any values, but take a look at the arrows to give you a little clue here. How do you know it's balanced or unbalanced? What's your clue with the arrows to help you out there, even though you don't have any values? 6, just kind of a little step up from what we saw here in number 4. Now there's a net force given to you. Net force is given. It's already been determined. However, there is a missing force. So I kind of have to work backwards. Now I do have to take into account, again, that arrow length, because I know when I do my subtraction, I'm always doing big minus small. So that's going to impact my net force. So looking at these first two, I've got 13 over here and a mystery over here. Well, looking at the arrows, I can see this is clearly the longer of the two. So that's going to be my big. 13 minus x, right, a mystery number, is going to give me 8 newtons. So I want to solve for what that's going to be and fill it in on the blank. I forgot to point out, I also have the clue here that says the direction is left. So that's, again, what I'm looking for with the arrow. So same deal, you've got a net force and one value. You've got to do your subtraction problem to figure out that missing. Now again, here we've got a challenge one where we're looking at the opposite as we work calculating. So I know this is moving to the right. I've got to think about, well, what's happening with these two values if it's not moving up or down? And then what would my value be over here to end up with that net force? Number 7, you can do that one after you complete those. Just a little observation of those diagrams. Number 8, Here we've got forces acting on a box being pushed across the floor. Again, you've got the net force, so this is a lot like that previous one. Again, you're working the opposites. So just a reminder there. So here we have the net force of 0. So what's that going to mean for the opposing forces if everything totals up to 0? And I'm asking you to show your work just so that when you do end up with a question, you can screenshot this and send it out to your teacher so that way they can see your thinking, versus when you just say, I'm stuck on number 8. We don't know what you've thought about already. So showing your work and using different colors is super, super helpful. These last few are all about acceleration. So a race car going around a corner. Remember, race cars travel around that circular track. So as that race car comes along the straightaway and wraps around the corner, even though it's going at a constant 200 miles an hour, what's that rounding the corner going to mean for its acceleration? So give us a yes or no, and then your reasoning, trying to keep those keywords in there of speed and direction. Great. Airplane at a constant speed. So the airplane is already flying. It's reached its flying altitude. It's going at 500 miles an hour at a straight line, headed for its destination. What would that be for acceleration? Yes or no? And again, see if you can get those keywords in there. And finally, the last one here, a football being thrown from the quarterback to the receiver. So the football is going to go something like this, from the hands of the quarterback through the air, caught with the receiver. Okay? So again, a yes or no, and your reasoning, keeping those keywords in mind, speed and direction. Cool. Now that you've gone through and tackled these, your teacher is also going to give you access to a key. Okay, so you can go back, see the kind of finishing of the problem, and make sure you've got all the information set to go. And again, as always, reach out to your teachers, take a screenshot of the one that you're thinking about, maybe even write a question on there and go, I'm stuck here. This is where I got to. I'm not sure what to do next, or how did I do? That's the best way to reach out at this time if these videos